In this video, we talk about chain rule with implicit functions, which is from section 14.4. We first look at the formula. So we have an implicit function fxy equals 0. Then our question is, what is derivative of y with respect to x? The answer is negative fx over fy, where fy stands for f derivative with respect to y, and we do not allow zero denominator. In other words, the condition has to be fy is not equal to 0. We can quickly look at how to derive that. So suppose you have fxy, a function of two variables. Then the change in f is basically, suppose this is smooth or first order derivative exists, then partial derivative with respect to x times change in x, partial derivative with respect to y, and change in y, and a small value depending on change in x and change in y. And this O notation means very small. By small, we mean it is getting to 0 or ignorable when delta x and delta y goes to 0. And when I put it into limit behavior, in other words, when delta x, delta y goes to 0, the whole thing can become 0. And in that case, we comes into differential of given functions. So delta becomes d, which means differential. Originally delta means change. Now d is differential, which is fx, and delta x means dx plus fy dy. Now because fxy equals 0, so df is equal to 0. Because this constant does not change, 0 is constant, d0 is 0, constant prime is 0. So that means fx dx plus fy dy equals 0. This eventually gives, if we rearrange two terms, then dy dx is negative fx over fy. And we want to impose a condition for the denominator being 0, not being 0. All right, so we are going to look at this question, example 5. Y squared minus x squared minus sine xy equals 0. This is an implicit function, not explicit function, because you are not able to write it into y equals f of x. So you cannot isolate y entirely, or you cannot solve for y from left hand side. So y and x are mixed together. You cannot separate sine xy in any algebra. So that means this is implicit. Now for this implicit function, we're going to use previous formula to get the dy dx. So this is the question. I want dy dx. So as usual, we set the left hand side as f of x and y. So the left hand side is a function of x and y. Now from the formula we're given is, it is negative fx and fy. Now, what is fx? It's the partial derivative of f with respect to x. In other words, we want to freeze y and just take derivative of x. So for negative 2x squared, it's negative 2x, and for negative sine xy, so I put negative first, and sine xy, we have to use chain rule, so it's composition sine xy. Then the sine derivative is cosine, and whatever it comes from, and multiplied by chain rule, multiplied by xy derivative, but remember we are taking derivative with respect to x. So y is constant. So xy derivative with respect to x is y, because y is just coefficient. Instead of writing y behind, I'd rather put y in front of cosine. So y cosine xy. Now fy, which is now becoming y is a variable, x constant. So y squared is 2y, and negative x squared becomes 0, and negative cosine xy and chain rule xy derivative with respect to y, that means x is coefficient. So the answer is dy dx is negative fx, negative 2x, negative y cosine xy, and 2y minus x cosine xy. Negative and negative becomes positive, so it's better to write this as positive, and we are going to erase this negative sign, and maybe this plus sign. All right, next. What if the left-hand side is 3-variable function, and now we consider z as dependent variable and xy as independent variable? So in other words, z is a function of xy. Then for this case, we're interested in, so if z is fxy, this is explicit. Then we recall that its first order derivative is usually partial z partial x and partial z partial y. We have two formulas required for the first order. Now if z is not solvable from implicit function, then still we're interested in partial z partial x and partial z partial y. And the formula is just given by negative fx fz and negative fy fz. So what you can think of is for proof, it's very similar. So we can look at change in f, which is fx dx plus fy dy and fz dz. But for partial z partial x, y is frozen. Y is frozen. You don't. So in other words, dy is going to 0. So for dy is 0 because y is just frozen as constant. And also, if you take differential both sides, 0 differential is just 0. So that means fx, so df equals 0. So df equals 0. So we can write this as, and this result conclude the first formula. The second formula is similar. And always we want to avoid 0 denominator by imposing this condition. So we have here implicit function, but there's three variables on the left-hand side. And z is a dependent variable and xy independent variable. So we look at partial z, partial x, partial z, partial y. And at the target point, 0, 0, 0. Why is that too small? It doesn't. All right, here's the example. I'm going to look at partial z, partial x first, which is negative fx fz. Now here f is given as these four terms, sum of these four terms. So we first look at fz, the denominator. In this case, we are going to take derivative with respect to z. So other things just like constant. So 2z, because x cubed, the first one is just simply 0, constant prime. And for this, we have y as coefficient, constant, e to the xz. In this case, we have e to the xz with respect to z. Then we use chain rule, so e to the something is itself, derivative, and then take the derivative of this box. But this prime is with respect to z, so e to the xz times x. Xz prime is x because with respect to x, with respect to z, x is considered as constant. So continued from here, plus y times exz prime is here, x exz, plus z cosine y. Cosine y is constant because z is considered as variable. Now, what is fx? Fx is going to be 3x squared plus z squared with respect to x. When we take this with respect to x, then we can just consider this as constant. So z squared plus, for here, the third term, y is constant and z is constant. So we can have y times e to the xz and xz prime. Now, prime means with respect to x, so which means z, plus the last one, it has nothing to do with x, so this is basically 0. Now, if we look at partial z, partial x, then this is 2z plus yx e to the xz plus cosine y. Oh, this is going to denominator. And 3x squared plus yexz times z and plus 0. And I won't put x, y, z as 0 because the target point in the problem is 0, 0, 0. So we replace every x, y, z's are as 0. Then the numerator is 0, denominator is cosine 0 is 1, so denominator is 1, so this becomes 0. We can also do partial z, partial y, which is negative fy, fz. And fz is already available. So we know that we only need to take fy, which comes from this f. So If we look at here, the first two terms take derivative with respect to y becomes 0. This term, because y is variable, this is constant, so e to the xz. And the last term is z constant cosine y, negative sine y. So negative z sine y. And we have f. So we have partial z, partial y, and equals negative, denominator is the same as fz, and numerator is exz minus z sine y, and take 0, 0, 0, replace everything by 0, every variables, and that means the numerator is 1, denominator is also 1, which gives me negative 1. All right, this is the end of this part. Thank you.